Innovation in design and the use of premium materials are only meaningful when they translate into superior products and performance. Our unwavering commitment to delivering top-tier performance for every diver demands intelligent design, expert engineering, and meticulous manufacturing. Proudly based in California, USA, Atomic Aquatics produces its breathing systems at our state-of-the-art facility, Atomica. Nestled among aerospace and technology firms, Atomica adheres to California's rigorous environmental and recycling standards. This ensures that our critical components are not only manufactured in-house, but also assembled under our stringent criteria, guaranteeing the highest quality and performance for our divers. The process of crafting a breathing system embarks on a bi-weekly delivery of raw metal bars, ranging from 1/4 to 1 3/4 inches, or 6 to 45 millimeters, and extending up to 15 feet or 4.5 meters in length. These bars, comprised of brass, Monel stainless steel, and titanium alloys, are selected for their unique properties, setting the foundation for the creation of a superior and precision-engineered breathing system. To guarantee the seamless feeding of metal bars into our machines, the ends of each bar undergo a beveling process. This precision step significantly reduces the risk of jams, minimizing the potential for delays and downtime in our manufacturing processes. Each machine in our facility is dedicated to creating a specific component in the required quantity, organized in batches. This batch processing allows the equipment to operate continuously for hours, if not days, before any change in parts is necessary. The tool heads, composed of carbide and cobalt, are strategically positioned to machine the metal. Depending on the material, these tool heads may need to be changed during the manufacturing run of a particular component to ensure precision and efficiency. The smallest diameter bars of material are employed to craft components such as orifices, low-pressure, and high-pressure plugs. A machinist loads multiple bars into the machine feeder, programs the job, and initiates the process. The machine consistently produces titanium orifices until it exhausts the material, or the stop button is pressed. Periodically, the machinist retrieves the manufactured units, conducting quality checks to ensure they meet our stringent standards for finish and dimensions. Even when machining larger components, like brassed-in nipples and swivel parts for the Atomic Aquatics hose, the same level of attention is dedicated to meeting requirements. The process remains consistent, underscoring our commitment to precision and quality across all components. Machining stainless steel and titanium poses the greatest challenge to our equipment. Whether crafting a stainless steel piston for our prize first stage, demanding additional compliance checks during manufacturing, or machining the titanium body for the esteemed Atomic Aquatics T3, the process requires precise care. To mitigate the impact on equipment, a lubricating cooling fluid is circulated throughout the cuts. In the case of machining the titanium body of the T3, seamless execution is imperative. Once the skilled machinist initiates the process, it takes just over 20 minutes to complete one half, followed by another 20 minutes to finalize the manufacturing process. This precision ensures the highest quality and performance of our products. Once the required batch of components is machined, the crucial step of cleaning ensues. This process is vital to eliminate any manufacturing damage or failures, and it also serves to remove metal burrs. The components are tumbled in different sizes of pellets, aiding in smoothing the surfaces. The duration of this cleaning process varies depending on the part, ranging from as short as 15 minutes to as long as 24 hours, ensuring meticulous attention to detail for each component. After the tumbling process, the parts undergo rinsing and sorting before entering a sonic bath. This method utilizes cavitation bubbles induced by high-frequency pressure waves to agitate a liquid. To conclude the cleaning process, every part is rinsed in fresh water before being placed in a drying cabinet. Subsequently, after the manufacturing process is completed, the part transitions to quality control. Technicians thoroughly check each dimension of a component and assess its final finish. A specialized machine called a profilometer is employed to measure the profile and surface finish with unparalleled precision. This tool can detect even the most subtle differences in the finish profile of a regulator's moving parts. Once the final quality checks are completed, the components are expertly packaged and prepared for shipping. On the other hand, our flagship titanium parts, having completed the machining process, are sent to Atomic Aquatics' own assembly facility in Costa Mesa, California, ensuring the highest level of control and care in the assembly of our premium diving equipment. Every Atomic Aquatics breathing system is constructed from 3 essential units: the first stage, second stage, and hose. Each of these components requires precision machined and/or coated parts sourced from our Oceanside facility. Upon arrival, each incoming delivery undergoes thorough checks for finish and quality to ensure that only the highest grade components contribute to the construction of our premium diving equipment. Hoses at Atomic Aquatics are cut from 750-foot or 230-meter spools to the required length and then undergo skiving. Skiving involves removing material from each end of the hose to facilitate the fitting installation. This process is used in manufacturing the Atomic Aquatics swivel hose. Once the metal end caps are in place, each end is crimped and date-stamped, offering precision and quality in the final product. As the technician begins assembling the first stage, components are gathered and ordered for swift efficiency. Each part undergoes a visual inspection, guaranteeing that threads, finish, and seals meet the required standards. Custom-made tools, designed to enhance technician productivity, are utilized in the assembly process. The formation of the Atomic Aquatics first stage follows a nearly identical process for each model, with the only variation being the alloy of metal used. After the assembly of the first stage, rigorous testing and adjustments are undertaken to ensure the correct interstage pressure is achieved. Both dry and wet testing are conducted at 400 psi or 35 bar and 3000 psi or 200 bar. The objective is to identify any functional issues, whether they involve leaks or pressure-related concerns. Technicians carefully listen for audible leaks during the testing and observe for bubbles in the wet test. If adjustments are necessary, the technician opens the first stage and takes corrective action to ensure the highest performance and reliability of the product. The adjustment process then begins again. Similar to the first stage assembly, the assembly of the second stage begins with the gathering of components. Skilled technicians bring together cleaned metal parts and molded plastics, completing a breathing system puzzle. The titanium inlet tube is carefully prepared, incorporating O-rings, springs, poppets, and the patented seat-saving orifice. Serving as the spine of the second stage, this inlet tube ensures the effortless breath of an Atomic Aquatics regulator. Once the inlet tube is complete, the main body of the second stage is assembled, integrating the automatic flow control, lever mechanism, and exhaust valve. Finally, the diaphragm, purge button, and retaining ring are added to complete the second stage, making it ready for adjustment. Prior to any adjustment, a trained breathing system technician conducts a test on the newly assembled second stage using low-pressure air, carefully listening for any leaks. Once satisfied, they proceed to breathe through the regulator while observing the Magnehelic testing gauge. This gauge provides a visual measurement of the inhalation and exhalation effort. If the effort does not align with Atomic Aquatics' strict guidelines, necessary adjustments are made. After confirming satisfactory breathing effort and construction in air, the regulator undergoes submersion, and the purge button is pressed. This step reveals any smaller, unheard leaks. If the second stage successfully passes these tests, it is moved forward for final assembly. After passing all tests, the hose first stage and second stage components arrive in batches for final assembly, culminating in over 20 labor hours of detailed work. Working in batches of 10, the technician first connects the hose to the second stage, testing the operability of the Atomic Aquatics swivel. Subsequently, the first stage is connected, with each connection meticulously tightened to the engineer's required torque. Racks of completed regulators hang as skilled technicians continue their batches, and once full, the racks are moved to testing. Utilizing ANSTI machines, Atomic Aquatics tests regulators in simulated diving conditions reaching depths of up to 165 feet, or 50 meters. The results are logged and attached to the breathing system's serial number. After testing, racks are transferred to the final cleaning and packaging area, representing the last opportunity to ensure the finished breathing system is flawless. Fingerprints and marks are meticulously wiped away before everything is carefully placed in its box. The finished regulator, impeccably packed in its box, is then shipped to our Salt Lake City warehouse ready for worldwide distribution. At Atomic Aquatics, we never forget that we are building life support equipment. Our dedicated and skilled team of engineers, machine operators, and assembly technicians have undertaken countless quality checks, performance tests, and adjustments. We ensure that an Atomic Aquatics regulator system will never leave our facility unless we are completely confident and satisfied with its performance, knowing that divers rely on it to effortlessly breathe underwater. We uphold the highest standards, treating every regulator as if we would be happy to dive with it ourselves.